Hello. So I've been asked to do a video on some of the sheet metal features in SolidWorks, and there are um, a lot of tutorials on YouTube and other learning resources for this on the web. So I'm just going to focus on a couple of uh, tools that I think are applicable to what we do on this team, along with some practices for design of fabrication and uh, design of sheet metal that I want to implement on our team. So the tools we'll be looking at today are the base flange tab tool and the edge flange tool. So in this video, I'm going to be using examples of sheet metal parts from our 2020 robot, and going to be creating the sheet metal features, the basic sheet metal features of this battery box and of this collector mount gusset there. So let's take a look at the battery box here. So what we're going to do is create a single sheet metal feature that has this entire profile on it, and use that as the basis for this part. And so what we're going to do is just create a new sketch. Now then I'm going to sketch out this profile here, and okay, so that's the shape that we want to create. So I'm going to go now to the sheet metal tab and select base flange tab, and this creates a sheet metal feature that follows that profile based on your sketch and these settings here. And this will put one side or the other of the metal along the sketch that you've created. And so I recommend designing parts like this so that the sketch follows the most critical dimensions of the part. And in this case, the most critical feature is going to be this width here that the battery fits in. And so this dimension is the width we need for that. So we're going to want to actually put the metal on the outside. And to do that, we come to the sheet metal's parameters, thickness, and reverse the direction. So now everything's on the outside of this sketch. So we also have a parameter. So we have the thickness parameter and the radius parameter. And you can't just arbitrarily choose any radius for the bed radius. It has to be a radius that the tools you have supports. And in our case, we have tooling for 1/32 inch radius and a 1/4 inch radius. And since we want the battery to be able to fit in here, we're going to want to go with the smaller 1/32 inch radius, because if you have a large radius here, the sharp corner of the battery is going to interfere with that when you try to insert it into the box. So I'm going to show you here is part of a design standard document that I've created for the team. And this shows you the maximum thickness of materials for three different aluminum alloys that you can use with each of the 1/32 inch radius and the 1/4 inch uh, radius bins. And so on this part, we had a 1/8 inch thick material, and we want to use the 1/32 inch radius. So that means we have to use the 5052-0 material. So because we can use anything less than 1/8 inch with this material on the 1/32 inch band. So you may notice that this material, you can use the thickest material on the of it on each bend radius because it's the most bendable, but it's also the weakest. The standard metal we use for pretty much most applications on a team is 6061 T6. That's kind of the default aluminum for most applications, but the 5052-0 is about 1/4 of the strength, I believe, and this H32 material is, I believe, about 2/3, I think, strength of the 6061 T6. So you'll have to take that into account when making your material selection. But so this, and you're going to need to obviously note the material on the drawing so that the fab team knows what to use. So we're going to select the 1/8 inch material here. This radius was already set to 1/32, so that's fine. So then that meets the criteria from the chart I showed you. So you can just click OK, and then we have a section with the same profile as the battery box I showed you. It's not the full length because I forgot to fill in the length parameter, which is this here. I'm not sure what this is, but I'm going to say it's about 7 inches. So that should look more like it there. Now, last thing I want to discuss about this part is these cutouts here. You can use a regular cut extrude feature to create those. I'm not going to show you how to do that because you should already know how to do that if you're watching this video. But what I will say is that the cutout should be at least 1/4 of an inch away from the tangent edge of the bend line there. If it's less than that, then you can end up with you'll end up with some distortion around here after you bend it, and that caused a big problem for us in 2015 because when the material distorts like that, it can also shift to the part and throw off the location of the bend. So next I'm going to show you how to create this collector mounting gusset, which and the main difference between this and the battery box is that this part has bends that are non-parallel to each other. So to create this, first we're going to sketch out the triangle, which will be the basis for our part. And then what we're going to do is use the base flange tab tool again. And so this tool works both with open profiles, like we used for the battery box, in which case it will create a sheet metal along the lines that you've drawn and include all the bends automatically, or you can use it with closed profile parts like this, in which case it will add like an extruded boss feature. So I set the thickness to 1/16 of an inch and hit OK. So now we're going to create the bends, and to do that we're going to use this edge flange tool, and then you just select the edges you want to bend. So you want that one, and you want this one, and you can create as many bends as you want at a time using this feature, but they'll all have the same properties. You do that. And so I'm going to make the flange length 1 inch, and you can note that the way we have it, the settings right now, the outer edge of the bend is where the edge of the base material was, but we can adjust that with these options down here. For example, we can adjust this so that the inside of this material lines up there, or put the entire bend outside of the material. Normally and well, which option you select usually depends on which side of the flange you're going to attach to. I'm going to be attaching to the outside of the flange, so I created this base flange with the outside dimensions I wanted, and then used the material inside option for that. So, and once again, I'm going to set the radius to 1/32 to match the bending tools we have. Then this here sets the gap distance, which is the minimum distance between in this corner right here. I'm just going to leave that alone, but you can change that if you want. Alright, so there's the part, except for the holes, which you should all know how to do. One thing I will say about the holes is, as I mentioned with regards to fitting the battery in the battery box, the tolerances that we can achieve on bending in-house are not especially tight. Um, so whereas um, and while nothing has to actually fit inside this part, depending on where the bend lines end up, your hole positions relative to the different edges of the part are going to vary. And because of that, for parts like this, I'd recommend match drilling the holes on all but one of the edges, um, and perhaps all of the edges, depending on what your application is on this part. Because if you drill the holes prior to bending, then the holes will probably not line up. So the last thing I'm going to but before we move on, just want to mention that it is of course possible to use a combination of uh, it's possible to use these edge flanges with parts that have been created in the manner that we created the battery box earlier. So you could, if you wanted to, go back to the battery box part and add some edge flanges onto that. So last thing I'm going to show you is over here we have this flat pattern folder, which contains a flat pattern feature. And if you unsuppress that feature, that will flatten the part out for you. And it'll also give you a bounding box that you can measure if you want to know what the size of the stock that you need to cut this out of is. So if you're going to send any parts, any sheet metal parts with bends in them to be cut on the water jet or on the CNC machine, you'll want to uh, flatten the part like I just showed you prior to exporting it. Also, you may need to you'll probably want to create a flat pattern in the part drawing that you can hand off to the fabrication team so that they can cut the parts in cases where it's not water jet cut or CNC. So I'm just going to show you how to insert a flat pattern into a part drawing really quickly. So you can just so when you create a new drawing of a sheet metal part, then the flat pattern will just show up over here as one of the uh, views that you can add. Alternately, if you use the model view option, then you can come to this drop down and select the flat pattern as your configuration. So at least by default, this doesn't show the bend lines like the flat pattern that's added from the view palette. on the right. So that's all that I wanted to say today. So hopefully that was helpful, and thanks for watching. Bye.